This is Physics Optics video number 2. So this is the same device that I was using earlier today. I'll kind of look down at it and you can see it. So what you have over on the right is the blue light is coming out on the right, and then it's aiming left. So there's a red light over on the left, and that's aiming to the right. It's bouncing off of a mirror to go that way. And then in the front is a green filter. So the green light's coming out the front. So let's see what we have here. We have white in front. Looks pretty white anyway. It's not bad. And then we have a patch of cyan over on the right. And then way over on the right we have green. And then over here we see that we have a little bit of yellow to the left of the white spot. Okay, so let's try to figure out why we're seeing what we're doing. Well, in the middle is all three colors together, the red, blue, and the green, all together, and that's making white as it should. So over on the right of the white, though, there's only a little bit of, there's a patch of cyan over there. So why is that? Well, if you see what's happening, again, the red filter over here on the left is aiming to the right. So that light's coming across the box and going over to the right. Well, the problem it has is that when it comes out and then it gets aimed over to the right, that eventually it gets blocked by the box itself. So if the red light can't get over there because it's blocked out by the box itself, then what do you have left? Well, if you have white light and you take out the red, what you have left is blue and green. And so that's why that patch over there is cyan. On the other side of the white spot is yellow. Now why is that? Well, that's because over on the right side of the box, you can see it down here, the blue light is coming out and it's heading left. And so when you block out the blue light from white light, what you have left is yellow. So in the middle we have white, on the right we have cyan, and on the left we have yellow right now. Okay, so what we're going to do, well, this is really your first example of subtraction of light, right? So if you have white and you subtract out red, what do you have left? Well, you have blue and green. And so that's why you see cyan again over on the right side. And then over on the left, if you have white light and you subtract out the blue, what do you have? Well, you have yellow left, okay? So that's color subtraction. That's subtractive mixing to start with. Okay, now we're going to do some with shadows, all right? So I'm going to put a marker right in front of this. Okay, let me just a little bit further back. Okay. All right, so now you can see three shadows there made by the marker that's right in front of it. Okay. The shadow on the right, far right over there is cyan. The middle one is now magenta. So you're asking yourself, maybe you're asking yourself, how come the shadow that's behind that marker is magenta in the middle? Well, let's think for a second. What color on our light box here is in the middle? Well, it's green. And so if that's getting blocked out by the marker, what's white minus green? White minus green leaves blue and red. So when you subtract out green from white light, what you have left is magenta. So the shadow that's in the middle ends up being magenta, because white minus green is magenta. The shadow that's over there on the left, the yellow shadow, is yellow for the same reason that spot over to the left of the white spot was yellow before, is because that blue light is heading that way and it gets blocked out in that direction, in this case by the marker. And so if you have white light minus blue, then you get yellow. So that's subtractive mixing. And so what happens with colors, with pigments, is essentially subtractive mixing, which is like what we're doing right here. Okay? So I'm going to move the marker just a little bit closer to the screen now. And if you look really carefully, you can start to see overlaps of the shadows. So overlapping on the right, looks like there's a strip of dark blue in there. Now, why should there be a strip of dark blue in there? The magenta shadow is crossing over with the cyan shadow. And so the only thing that's left that they have in common between them, remember, magenta is red and blue, and cyan is blue and green. And what they have in common is blue. So the only thing that's not blocked out between the two of them is blue. So that shadow is blue. if you look at that shadow that's to the left of magenta, it's red. There's a strip of red there. Now, why should there be a strip of red there? Well, magenta has blue and red in it. Yellow has green and red in it. The only thing that they have in common then is red. And so in this case, those two shadows overlap and you get a red shadow right there. So that's a little introduction to subtractive mixing. Now, as I said earlier, I probably said this on the email, there's a couple of little things that I want you to do. One is make a prediction on this video for what will happen if I put, instead of having the green filter in the front, if I put the blue filter in the front, blue in front, red on the right, and green on the left. Okay? So get this, blue in front, red on the right, green on the left. If I put the marker in front of it, just like I did before, what will be the pattern of shadows that you'll see? That's the prediction that I want you to write in the comments for this video. Physics Optics number 2. I want you to put your prediction down there for what the shadow pattern is going to be if I have blue in the front, red on the right, green on the left of the light box as you see it down here. Okay? So make your prediction about the shadows and put that in the comments. And then after you're done making that prediction and writing that in the comments, what I want you to work on the rest of the class period is the subtractive mixing Explore Learning. So this isn't like for homework per se. I think you should be able to get this done this class period. And again, I'll be around. If you have any questions, just shoot me an email. I respond to that pretty fast. And then, you know, we'll get in touch personally. I'd like to be able to get in touch with you guys personally on an individual basis, either by, you know, meetups or if email is sufficient, or through texting or phone calls, whatever I need to do to make sure you're getting a grip on these things. Okay? All right, so thanks for your good efforts on this. And remember to post your answer to that challenge down there on the comments to this YouTube video. And make sure that you do it during the class meeting time. That way I can take attendance and I can know you're involved. Okay? Thanks. Bye.